All right, welcome back. So we're finally doing just a empirical study, right? We've referred to a lot of empirical studies in the other papers we've read. The papers we've read have been largely sort of more higher level abstract sort of theoretical papers that list a lot of different studies as, support for their view or it's possibly challenging their view. Here we're just doing a straightforward, a hypothesis, testing that hypothesis. So this is an fMRI investigation of emotional engagement in moral judgment by Greene et al. What's the point of this study? We have seen some arguments already that moral judgments begin as these automatic, unconscious, system one judgments. Right? Start with our gut intuitions, and then reasoning tends to kick in later as sort of a post hoc way of justifying our initial intuitive judgments. So we've also seen an association between these system one judgments and emotion, right? And you also often see emotion contrasted with reason. So if moral judgments, as this right strain of theory that we've been dealing with claims, are not primarily rational, they might be to some degree emotional, right? And this would fit with Damasio's studies of right the role and Prince, the role of emotion in decision making, right? So Greene wants to test this and see if there is some involvement of emotion in moral decision making. And Greene et al. Think that it is, right? So their hypothesis is that yes, there is a statistically significant um, degree of emotional activity in the brain when we make these sorts of moral judgments. And if that's correct, they argue it will help us understand some data that is otherwise kind of puzzling. Here's what they mean. Here's what they're trying to explain. But I think you've probably heard of trolley problems for now, right? But just to review, so the original trolley problem, it's a thought experiment. Sort of test people's intuitions about the correct moral theories. So the original trolley problem goes like this. So here you are on the train track, if you can see that picture in the upper right. There's a trolley heading down a track. It is set to hit and kill 5 people that happen to have been tied to the track by some evil villain. You happen to be there, a witness, standing by a lever that if you pulled it, it would switch the trolley onto another track to which only one person is tied. If you pull the lever, one person is killed instead of 5, and people are asked, would you pull the lever? I ask you, would you pull the lever? Typically, most people say, yes, I would pull the lever. I would kill one person to save 5, right? If you call that killing, whatever that is, that pulling the lever, right, that causes one death, I would do it because, you know, there may be a gut intuition going on. There's certainly just a mathematical consideration, right? If killing is wrong, it seems, or death is wrong, or harming people is wrong, it seems like, right, 5 people suffering and dying is worse than one person suffering and dying. So you do the math and you think, save the 5, kill the 1. But there's another version of the trolley problem, right? And in this one, there is not a switch. There is still the trolley. It's still headed towards the 5 people, right, that will die if nothing is done. But instead of being near a lever you can pull, you are standing on a footbridge over the trolley. And you are near a very large man who's sort of, let's say, peering way over. He's very interested in the situation. He's leaning way over to see what's going on. You realize, if I were to just give this man a little shove, he would fall into the tracks. The trolley, it's not a full-on train, just a little trolley, it would hit and kill the big man, but then it would probably stop. His weight would be enough to stop the trolley, and so he would die, but the 5 would survive. And so we ask you, would you push the big man off the bridge, right? Um, most people say, no, I would not do that, right? Um, the math is the same, right? The only difference is instead of pulling a lever, you are actively pushing someone. And that seems to most people to be a salient difference, right? And they give a different answer, right, to the question. Uh, so what could explain this, right? Why do people give a different answer, even though, Again, the math is the same. Well, one proposal has been that the difference is in the lever situation, you're not killing the person per se. You're letting one person die, right? Or you might describe it that way. Whereas in the other situation, you're actively pushing the person, which you might interpret as actively killing. Maybe it's an active passive distinction that's going on here. So, for example, if you've ever studied Kant in an ethics class, he has what he calls the categorical imperative, which is his sort of most general rule of morality. And that rule says you should never use a person merely as a means to your own ends, right? You should always treat people as an end in themselves, and you should think about what they want, their desires. You can't just use them for your own reasons, right? And it seems like in the second scenario, you're definitely using the big man, right, for your own ends, right? Even if you think it's a moral end, you are using that person, right? You're not asking them, hey, do you mind if I push you off the bridge? Or you're not persuading them to jump off the bridge, right? You're just using them to save the five. So if you think that's distinction, right? So maybe Kant would say pulling the lever is okay, right? You're not using that one person, but in pushing the man, you are using that person. So that's why pulling the lever is okay, but pushing the big man is wrong. Um, Maybe, right? But then what philosophers and moral psychologists have done is cook up other scenarios, right? Um, so you can cook up a scenario that just involves pulling a lever, but still involves using a person, right? So the way those work is like it makes it essential to kill the person, right? So it's like a track that would loop around and kill the five, right? Unless you pulled the lever and made it hit the one person and stop after killing the one person, right? So you can cook up a scenario where you're still pulling a lever, but it's essential that the one person dies, right? In the original scenario, it's not essential the first person dies, right? The one person, if they happen to untie themselves and get off, so much the better, right? But in this other scenario with the twisting track, the idea is it has to hit and kill the person for the trolley to stop, right? So, but it's a lever instead of pushing. And in those situations, people typically say, "Yeah, I'll pull the lever," right? So the twisting track version does violate Kant's imperative because you are using that person as a means to save the other five, right? So the whole point of that being, right, it's whatever's going on in people's heads. It's not that they're worried that they're going to violate Kant's categorical imperative and actively kill someone instead of passively kill someone, right? Um, it's something else, right? And Greene's hypothesis is that what's going on is when you imagine pushing the big man, your emotions engage in a way that doesn't happen when you pull the lever. And if he's correct that emotions, right, are involved in these intuitive system one moral judgments, then that would explain why when there's emotion involved, you get a different judgment than when there's less emotion involved. So if Greene's hypothesis is correct, right, that the difference in the judgments in the trolley cases caused by differences in like level of emotional engagement, um, then we should predict more activity in areas of the brain associated with emotion when people are thinking about what to do in the big man case, right, as opposed to the lever case. And we can measure that. We can check that out and see if that's the case. It's called fMRI, right? So it's a you, you put your head inside a giant spinning magnet thing, um, and it measures the blood flow in your brain. And the idea is if there's more blood flowing in a particular area of your brain, then that means that area of the brain is active. And we already know from other studies, right, which areas of the brain are active when people are emotional, right, when they're engaging their emotions. So that's one prediction, right? We'll ask these people run these trolley problems, see what parts of their brains are active, and the idea is when they're dealing with the big man problem, there's going to be more activity in the emotional areas. Um, Greene also offers a behavioral prediction. Uh, so we to do this one, you don't have to put people in the MRI machine, right? The idea is if people's emotions are being engaged in the big man case, um, right? They're having one sort of rational uh, they're making one sort of rational conclusion, which is the one they would do in the lever case, right? They're doing the math. But in the big man case, they've also got this emotional thing going on that's pushing in the opposite direction, right? So they're sort of being pulled in opposite directions. And the idea is that this interference is going to make them slower to respond to the question. A little bit of tension. It's two processes happening at once that are in tension with each other, and it's just going to slow down their processing. And so they're just going to, it's usually on a computer, but it can be verbal, right? Because the computer is good at time measuring the timing of stuff. So it takes them a little longer to push the yes button, right? When they make provide their answer to what would they do in the big similar. So this idea of like interfering processes that is used a lot in psychological studies. A classical one is called the Stroop task, right? So they flash, you know, uh, they flash words right on the screen, and they might ask you what word is here, or they might ask you what color is the word. And it's super easy when the word is green and the color is green, right? A lot harder, people slow way down if the word is green, but the color of the word is red, right? Because there's two different processes. You've got your sort of like syntactical or your semantic process, right, where you are reading the word green, and you've got this other visual process where you're detecting the color, and they're sort of in tension, right? They're reading opposite things, and so it slows down the whole process, right? So this is like the Stroop task, but it's emotion and reason that are in tension instead of your verbal part of your brain and your visual part of your brain. Okay, so here are the details of the study. So he develops a battery of 60 different scenarios, right? So not all of them are trolley problems. There's all kinds of problems. And then in an earlier pilot study, he got people to categorize them as moral or non-moral, right? So, and they try to, they get more than one, many people to do this. And sort of if, the vast majority or statistically um, sufficient majority of people say that, yeah, this is moral, then they put it in the moral category. If they say it's not moral, they put it in the non-moral category. If something's sort of fuzzy, they might just throw it out. So an example of a non-moral dilemma would be, uh, oh, should I travel by bus or train, given that, the bus takes this long, the train takes this long, and I need to be right at my job by this time. So, that's a dilemma, right? But it doesn't really have any particular moral valence, right? It's just about, getting to work. That'd be a non-moral dilemma. Moral dilemmas would be like trolley problem. There's other ones like, should I steal someone's organs to save five others? Should I throw someone off a sinking lifeboat to save the rest? Things like that, right? Typically stuff where have to sacrifice someone to save others or something like that. They also, so besides categorizing them as moral or non-moral, they also had people categorize the scenarios as personal, i.e., emotional, or impersonal, i.e., not emotional, right? So um, pushing right the big man off the bridge would be personal, right? It seems to involve emotion, right? Um, Stuff like should I found some money in a wallet, should I keep it? That's impersonal, right? It doesn't quite fire the emotions in the same way as pushing someone off a bridge does, right? So they've got to, should I vote for this policy even though it would cause some deaths, but it would also save some lives, stuff like that. So those are moral dilemmas. That's a moral impersonal dilemma where it's got a moral valence, right? There's a right or wrong involved there. It's not just convenience, but it's not necessarily super emotional, right? You're people you don't know, you're voting on a government policy. So we end up with sort of four categories, right? You've got moral personal, moral impersonal, non-moral personal, and non-moral impersonal, right? So we've got all these 60 scenarios, and one of these each is in one of these four categories. So the subjects in the study, and there were, I think they said nine, right? It's on the previous slide. Yeah, nine participants. So it seems like not a lot, but often this is the case in these psych experiments. They just need enough participants um, for to get a statistically significant result. Often, if they don't get a statistically significant result, they'll add more subjects later, right? Um, I don't know. They call that sometimes. That may or may not be like a great way to go about it. Right? So the fact there's only nine is actually not a terrible thing, right? If they kept adding more subjects to try to get it statistically significant, then you might be suspicious. But if they stopped at nine, that probably means it was already statistically significant, their result. And if you look at the chart here, it seems pretty obvious that it was. We obviously don't have to go into math. I never took the statistics course in psych, so I only know what the words mean, but I don't know how to calculate them. And most people don't. I don't know. It's a spreadsheet usually. But okay. So in each experiment, 9 participants, they listened to each of the 60 scenarios, right? Kind of exhausting, um, while in an fMRI machine and while having their reaction time measured in their responses, right? So they're uh, right the neural results and the behavioral results. And our results are here in figure 1 shows us the MRI results, right? So these are various parts of the brain, right? So we've got 4 areas associated with emotion: medial frontal gyrus, posterior cingulate gyrus, angular gyrus, and gyrus left and right. And then we've got, just for contrast, as sort of a control, areas associated with working memory, right? So that's not emotion, that's something else. So statistical analysis showed significantly more activity in brain areas associated with emotion in moral personal conditions. So the black bars are the moral personal conditions. So these are the pushing the big guy off the bridge type scenarios, right? And then you'll see that the black bar is way, way taller, right, in all of the areas associated with emotion compared to the moral impersonal. So if you, right, when someone is answering the question about should you keep money that you found in a wallet, um, their emotional area of the brain is nowhere near as active as when you ask them about pushing the big man off the bridge. Right? And then you look at the working memory, and working memory seems, I don't know if it's statistically significant because they're much closer, right? Um, but it looks like it's a little more active in the moral impersonal ones, right? Maybe they're thinking a little harder, right? Just doing the math. And the emotional, the moral personal ones, not particularly active at all, right? In the working memory areas of the brain. So this supports their hypothesis. And here is the behavioral results, right? Um, so I think I said they were they measuring? I don't know. I don't know if they were measuring reaction time in the MRI machine. I'd have to reread the thing, but they're definitely, this looks like experiment 2. This looks like a separate experiment, perhaps. So here they're measuring reaction time, right? And again, their prediction was that if you are, there has to be tension, right? So in the pushing the big man off the bridge, if you just instinctively said, no, immoral, that wouldn't be tension, right? So that should happen pretty fast, right? But if you are one of the person who's asked, would you push the big man off the bridge? And you say, yes, I would. There you have tension, right, between the rational and the emotional reaction. And that's where they predict a slower reaction time. And that is what they see. So you see that line, you have the dotted line, you have the line with the white boxes, and then you have the line with the black dots, right? So the black dots is the moral personal ones, right? And when people judge in those situations to be appropriate, so if you're saying yes, you should push the big man off the bridge, it's much slower, right? You'll see it's up around 6,700 milliseconds, right? Um, whereas if when they're judging it to be inappropriate, it's down around 5,000, right? Okay, so in both cases, their hypothesis is supported. So conclusion, yeah, both of their predictions were supported by the data. Personal moral dilemmas engage areas of the brain associated with emotion to a greater degree than impersonal or non-moral dilemmas. And reaction times are longer for subjects who answer appropriate in personal moral dilemmas than for impersonal or non-moral dilemmas. So does this data support the theory? It's consistent with it, right? I'd be curious to hear, this is the sort of thing you could write a paper on, right? Where you might say, well, um, I think there's other explanations of this data, or it's consistent with their theory, but it may also be consistent with other theories, right? Ideally, they don't want this data to be with both their theory and a competing theory, then it's not very helpful at all, right? That's something worth investigating if you have any thoughts about that. But we'll keep this one short, right? That's the goal of this one was to be short. And so this is at least one study that we looked at in a little more depth. I feel like looking at the other ones mentioned, finding them and digging into them, that might be a way to write a paper as well. All right.